Hello children, we know what are acids and bases. From our lower classes we are studying acids and bases. What do you mean by acid and base? We know, according to our definition what we studied, acids are the substance which donate H plus ions and bases are the substance which donate OH minus ions. These theories we know. But there are other theory of acids and bases. Over time, the theories will change. The theories were formed with lot of research and experimentation. So we'll see the Arrhenius theory, Bronsted-Lower theory and Lewis theory. So Arrhenius theory is the oldest one. Now we are using Lewis theory. That is the newest one. So we'll see each theory. This is two scientists formulated the Arrhenius theory. 70 Arrhenius. His full name is 70 Arrhenius. This is 70 Arrhenius. So his theory is known as Arrhenius theory. He was a Swedish chemist and a Nobel Prize winner. He was the first scientist who explained the nature behavior of acids and bases on the form of a theory. So we'll see what is Arrhenius theory or Arrhenius definition of acids and bases. So according to Arrhenius, acids are the substance which produce hydrogen cations or hydronium ions when dissolved in water. So according to Arrhenius, acids are the substance produce hydrogen cations or hydronium ions when dissolved in water. That is according to definition HCl, which gives H plus plus Cl minus. So HCl is an acid. Why it is an acid? Because if it is dissolved in water, it will give H plus ions. Hence, it is an acid. So according to him, bases are the substance which produce hydroxide anions when dissolved in water. So for example, if you take sodium hydroxide, it's dissolved in water, it will give sodium plus and OH minus. So it has the ability to donate OH minus or form OH minus. So it is known as base. This is Arrhenius definition. So only in aqueous solution is it possible. So that was his major drawback. So the next theory came, that is Bronsted-Lowry theory. So it is the broader definition than Arrhenius. So according to Bronsted-Lowry concept, acid is hydrogen donor. Acid is an hydrogen donor, that is H plus or H plus donor or proton donor. Base is hydrogen ion acceptor. Base is hydrogen ion or proton acceptor. And it will always come in a pair. For example, HCl is an acid. When it dissolves in water, it gives its proton to water. That is, if it dissolves in water. So, HCl plus H2O gives H3O plus ion and Cl minus ion. So, water is a base here. Water is a base, makes hydronium ion. Bronsted. So Johannes Bronsted and Thomas Lowry. These scientists combined, their theories were separate, but their theories were combined, and we are using Bronsted-Lowry theory. So according to Bronsted-Lowry theory, why ammonia is a base? So it is can be explained using Bronsted-Lowry theory. That is ammonia dissolved in water, which will give ammonium plus ion and OH minus. So ammonia is the hydrogen acceptor. You can see from this water, it is accepting hydrogen. Hence, it forms NH3, will change to NH4. From here, it is accepting one hydrogen. So from H2O, one hydrogen is removed and it is formed OH minus. So it is a hydrogen acceptor. So according to this definition, base is a hydrogen acceptor and water is the hydrogen ion donor. So here water is act as an acid. This causes the OH concentration to be greater than the pure water and the ammonia solution is basic. Like this manner, we can explain or describe the property of any substance. And one more thing is there, always acid and base comes in pairs. That is, a conjugate base is the charged particle of the original acid. After the donation, that we can see by an example, then it will be clear. Then a conjugate acid, there is a conjugate base pair and a conjugate acid pair. Thus, a conjugated acid pair is related by the loss or gain of single hydrogen ion that we will see by an example. For example, here you can see HA. HA, it's a general compound which reacts with which dissolve in water. It gives H3O plus ion and A minus ion. So for example, if you take HA is an acid, H2O is a base here, it form H3O plus. Here H3O plus is the conjugated acid and A minus is a conjugate base. So whenever an acid or a base dissolved in water, it will give a conjugated acid and conjugate base. So there will be always a pair, acid base pair. Here you can see ammonia, for example, ammonia which dissolve in water. Here we know ammonia is a base, water is acid, and here gives conjugate acid. How a conjugated acid form? From base a conjugated acid form. From acid a conjugate base will form. A substance which can act as a both acid and base is known as amphoteric substance. Here you can see water. Water, sometimes if it is reactive with a base, it is an acid. If it reacts with acid, it will become base. So water is an amphoteric substance. So then we'll move to the Lewis acids and base concept that we are using now. So his full name is Gilbert Lewis. He focused on the donation or acceptance of a pair of electrons rather than the hydrogen or proton. He considered the donation and acceptance of electron. We know if a reaction occurs, there is what happening there is the main process happening there is either the donation and acceptance of electron. So according to Lewis, he focused in the donation and acceptance of electrons. So for according to him, Lewis acid, it is the electron pair acceptor. Any substance which accept electron pair, then it is a Lewis acid. Any substance which donate electron pair, then it is a Lewis base. So for example, from our childhood we are studying the definition acid is an H plus donor. For this definition, we doesn't need the hydrogen. Isn't it interesting, no? So the scientist Lewis. So that is the correct definition of acid and base. What happens when acid dissolves in water? This process is known as ionization. Water acts as a base and abstract a proton. As a result, the conjugate acid and conjugate base will form there that we already discussed. You can see Arrhenius acid. These are things we are discussed. Okay. I hope you understood the acid-base theories. We will see more about this in next class. Okay. What are strong acid, weak acids, and solubility product and all we see in next class. Thank you. Have a great new year.